good afternoon. This session is in English because of two speakers that prefer English, I think, over Dutch. My name is Bob van der Zande. I am the Director of Building Wood in the Metropolitan Region of Amsterdam. And also welcome Herman Bloemer, who did the presentation before with great success, I hope. I wasn't there because I had to moderate another session. But I'm pleased to have you in the room. And please ask questions. The introduction is, of course, that building in wood and in bio-based is so much under attention now. There's so many people thinking about it, taking initiatives, designing, constructing, etc. And when I started 3.5 years ago, before I didn't do much with wood, the enthusiasm was great with many people, but so many people already did for a long time, like Herman, like Alex, lots of things in wood. And now that in the, you can say, the residential development, there's much discussion of feasibility, of technical solutions that should be in rules and regulations in the Netherlands. All kinds of discussions, and that's why for the third time we have this edition of Houtbouw XL. And I think we will continue in the next few years because we're not there yet. Every time there's new information, there's new experience, there's new insights from public sector, from private sector, from knowledge institutes, and especially knowledge institutes and education is what we're talking about now in this session. And I think it's very important, but let's hear about what the speakers have to say about it, that the generation that is now educated should think different than the last 50 years, you can say. And this is pretty new for many people. And I think the speakers are experienced in education and working with the younger generation. So we have 4 speakers. Alex de Rijke, professor in Delft. Applaus. Michiel Spaan, Academy of Architecture in Amsterdam. Frank Huijbe. Where's Frank? Frank Huijbe. Meest. Applaus. Bijbezig. And Marta from HVA and Robot Lab. Well, I'm not talking too long, so I would like to ask Alex to come forward and to have your presentation. And you told me before, please interrupt and ask me questions. Mm-hmm. Maybe I will do, but others can do too.
Yeah, please.
Yeah? This is the clicker.
Thank you.
And go ahead.
And thank you for understanding English so well. Because I'm a Dutchman in disguise, and you wouldn't like my Dutch, so thank you. I'm an architect in practice, and also have always been an educationalist. I guess I started working in timber when I was a graduate, doing my mother's house, the classic project, right? You have to rebuild your mother's house. I rebuilt a perfectly innocent house entirely in plywood taken from skips behind the Design Museum. Every time they had an exhibition, they threw away double A grade birch ply, and I couldn't bear to see it being thrown away. So I took it on the roof of a Renault 4 to her house in Cornwall and rebuilt it over a kind of 4-year period. And that got me into timber. Then I, luckily enough, saw the wonderful parasite project in Rotterdam. I was taking some AA students to a study tour in Holland, and I saw the parasite project Las Palmas, and that turned me on to engineered timber. And from then on, I've really focused on it. But I'm not going to show you any of my work. I'm going to show you the work of the students at Delft and of my colleagues at Delft. I'm kind of covering for a colleague here, Gilbert, who had to go to his daughter's graduation and therefore couldn't be standing here today. And what I'm doing is kind of presenting the work of others at Delft. And so forgive me because I can't go into massive detail because it's before my time. I got the job 6 months ago, and my own wood studio starts in autumn, which I'm really looking forward to. And I'll talk a bit about that. Anyway, there's an exhibition at the moment opposite the long line of chairs in Delft, which I love. They're the survivors of the burnt down Bakema School of Architecture, just the wooden chairs. And I thought this was really significant because the students at Delft made this publication. The first one, 1960, was a critique of their professor's work. And I think that's the culture that you exist in, which is so fantastically democratic. So you can bitch about the bureaucratic processes and the length of time it takes to make decisions, but you have the polar model, which is so valuable for an outsider who's existed outside of something so organizationally fair. I think it's amazing. Anyway, the campus historically is, of course, a manifesto for concrete and steel, and the Aula building is the centerpiece. Inside the campus are all these kind of enigmatic, brutalist buildings, you know, engineering oriented. The clue's in the name, right? The Technical University of Delft. And the reality is nothing about its origins was really about timber. And I feel really, really lucky to be able to be part of a kind of growing culture of wanting to work in bio-based materials against the backdrop of these enigmas, and with these incredible facilities, and none of which have historically had anything to do with timber. So this is the concrete and steel testing. You know, the robot there is for testing earthquake, you know, for, what's the word, impersonating, or, you know, it's basically a series of machines for compression testing, tension testing, and creating real-life scenarios like seismic activities, but none of it for timber. But in this context, there is this very important realization that in the construction industry, you know, say 40% of global emissions are based on the use of steel and concrete, and the manufacturing particularly. And timber far outstrips that, as do all bio-based materials. So there is an acknowledgement, even in every other discipline, that things are changing. Here's James O'Callaghan talking at a recent symposium we had called Future Envelope. It's a yearly conference, and he's presenting. He's one of the best glass engineers in the world. He's professor of glass at Delft. He's presenting a Singapore high-rise building where they used as much timber as they could, given the constraints of building over a subway and having to use steel for the primary structure. So even the professor of glass, let alone the steel and concrete disciplines in the university, are acknowledging the need for less carbon in the industry, of course. And inventions like this, you'll recognize the cast glass block from the MVRDV Chanel shop in Amsterdam, but you may not recognize the more recent developments in the glass for recycled and circular products. Anyway, the model hall here it looks really empty, doesn't it? It's obviously too early in the morning for students, but I think the point is this is normally absolutely rammed full of students, and they're all making timber models. They're not necessarily thinking their building is timber, but I think a lot of them are, as well as now using timber rather than like foam card or you know, plaster of Paris or even concrete models, which I think back in the day was the norm. This new culture is there. I'm not inventing it. I guess I'm asked to be a catalyst for what's already emerging. And there are many collaborations existing already. I don't even know them all. These are some I could find. For example, you know, working with people like Anna Beim in Denmark and the Royal Danish Academy, the inventor of the wonderful pyramid of carbon emission materials. But there are many more associations, you know, for example, with universities I've worked with, like Cambridge, like Royal College of Art, or associations I have in other countries like Pekka Heikkinen, the Poo Studio, the Wood Studio in Helsinki. So there are lots of potential collabs going on, and I'm standing here to welcome more if any of you are interested. So AE&T is the subdivision of BK, and it's Rijnkunst is obviously a broad church, and the architectural engineering and technology is a relatively small department compared to the size of the whole school. But on the other hand, there's a really nice crossover between students of urban design and architecture and digital fabrication and so on, and the department where we're more concerned with a focus on materials and components and how to make buildings actually work. This is a really great program, the MOOC, which has been developed by Professor Arjan van Timmeren. He's from urban design, and then Gilbert Koskamp from my department. Pierre Jennen, he's a docent together with Gilbert, and Pablo van der Lucht, who's a graduate you, I'm sure, all know about because of his publication work and his authority on bamboo construction. And Elizabeth Mignoni Alejandro, who I haven't met, but is also co-presenting on this online platform, which is a really amazing piece of work. I'm really impressed by this because it's a free online course for people who don't know about timber construction and want to. And so I'd advise you to get on it if you're interested in that, or recommend it to others. It's basically systematized. It's very modular based. It's very organized. It's there's a whole series of tasks that you can respond to. You have tutors that are from the list I just showed you. And the idea is that this is an interesting reference to the fact that it's so successful, the online platform, which has been up for less than a year. But already, in a quiz of students at Delft, where they were asked to identify, things that we probably think are standard. Can you identify, I don't know, stored Enso CLT or Lignature or whatever? They know nothing, virtually nothing. About 19% of the students could answer all the questions, even about the species of timber, whereas those who had done the online course were up in the 70s. So even from that perspective, I think it's been a really valuable tool as an extension to Delft's program. And the idea is to make a professional version for those of us practicing in the industry or perhaps at a researcher level, and for contractors. So that's another ambition of the program. I'm also going to show a few projects that, as I said, I haven't personally tutored or know particularly well. Gilbert has furnished me with the work, but I thought it's worth including. The studio masters were Gilbert and Pierre. And sometimes they're helping students from other disciplines, which I'll show in brief. So they organized this timber re-engineered platform, which included a symposium called Touching Cellulose, and this is something that I'd like to expand so that this year in autumn we'll have our own timber forum with really great selection of speakers from around the world, UK, Europe, and Scandinavia and Australia. So that's coming together, and I hope to really expand the ambition that this already established. This is really a kind of selection of examples that Gilbert and his colleagues have given students in order to analyze. So it's one working method where you learn from exemplar buildings, and the idea is that the students obviously do an analysis and have to draw it and really understand the constraints and the opportunities that timber offered to that particular building. So that's a kind of, very normal, isn't it, pedagogic approach to learn from masters. And then there are projects, for example, in other studios, like this is Nathalie de Vries, her studio, which is about public buildings, and this student wanted to do it in timber, so it's a quite ambitious, large frame project. It's beautifully rendered. It's perhaps not... perhaps this is, if I wanted to be critical, I would say perhaps this is an example of thinking in one material and building in another. So it's the discipline of a concrete and steel architecture, but carried out dutifully in wood. And I don't mean that in a disparaging way of any students, because of course you need to inspire and not squash them. But I do think that this student will have learned a great deal about, you know, what you can really do in timber and how you have to detail it differently. So that's that. This is, for me, a more interesting project from the archive that's from 21. I'm going in rank order here. This is a study in engineered bamboo for a residential tower. And I'll just show briefly these projects. So I'm not going to go into plans and details, but I think it's evidence of an ambition among students to make kind of non-standard architecture from standard products, you know, that are emerging on the marketplace. And this student has taken the challenge of high-rise that architects can't resist. You know, it's that sort of Boy Scout mentality, isn't it? How high can you go in wood? For me, I'm not sure it's necessary, but to make good cities out of towers. But this is I think, a very interesting tower project for its superimposition of different structural principles in order to provide a mixed-use program. And this is a quite elegant homage to, say, Aalto, who arguably is the modernist pioneer, I guess, of engineered timber, having been so closely associated with the prefabrication of laminated timber. And his furniture making its way into his building forms. So this is a sports facility in curved glulam. Ultimately, I guess you could say that architecture, there are many definitions of architecture. I love many of them. Like Van Lieshout's definition, which is useful art. But there's other definitions like shelter, which we all know, but perhaps another one is that architecture is nothing more than joints. It's just how do you join one material to the next, or even the same material to itself. And these are examples of student studies into that endless challenge of, you know, how you actually fix and generate architecture from the geometry of jointing. This is a 2-year ago project for a folly made out of 7 fallen trees from Amsterdam, involving 7 institutions or 7 different schools of architecture from around Europe, and one was from Norway as well. So it's a project that's really about organizing a team and collaborating in order to meet one magnificent aim, which I think was a chicken house. And the wonderful chance the students had was to not only have access to these complete trees and be responsible for the planking and the jointing and all of the fabrication issues and use the entire tree, but they could do it in a wonderful workshop that Lauren Brasse owns and has built entirely from recycled materials. The steel frame and all of the timber, the glulam, portals, all of it he's recovered through his network of circular materials. And it must be a rare example of somebody who's done that from their own initiative. If you're in the room, Lauren, forgive me for bigging you up, but I am impressed. And there he is on the left with glulam beams being glued up in order to test. So just a couple more things, because I'm showing parallel strands of studies, a bit like lamination, sorry, but I couldn't help that. There's Matt Salzberg's work. He's a PhD student that he's just made his proposal. He's working also in Technische Hogeschool in Köln, as well as at TU Delft. And his thing is beach doweling. So obviously we all know that a more sustainable future will be timber connections without recourse to steel. and laminated timber without recourse to glue. So what he's doing is beach dowel analysis and doing swell to fit or shrink to fit pegs and host timber studies. And this is a really fascinating proposal, I think, for a PhD. And he's someone from a carpentry background from Germany who's then become a kind of first-class student at Delft. You probably can't see the analysis here, but it's effectively measuring the compression when you modify timber, and then measuring the difference between conditioning and compression and cooling, the setback to its memory shape, and then the recovery. So he measures all of that and consequently makes design proposals for dowel systems. Yeah, I can skip. Anyway, if you want to see it, that's the title. It's in the It's in the Journal of Wood Culture, March of this year. Shape-changing wood joints in crafts and industry, and their potential for building construction and wood culture, which for me, I think, really is the future. So, this is what I'm proposing to do with my own wood studio together with Gilbert, and we're calling it TUD, Timber for Urban Density, and this is really about the crisis that addresses Nederland at the moment. In other words, the housing shortage and land value being too high or simply not enough land to do it. So we're saying this studio is dedicated to architecture that is either floating or on top of existing buildings. And obviously the palette is engineered timber and bio-based materials. And Gilbert Steen and I will have invited guests, for example, Mauro Parvicini, who's also at Delft, but then engineers like Kelly Harrison, who's a bit of an authority on op-top and from a commercial engineering perspective, and Lisa McSweeney from the architects White Architect in Sweden, and Daphne Swank from Amsterdam's Elephant Studio, also a TU graduate. So we're trying to create a program that answers relevant questions and also promotes the idea of a culture of timber construction at Delft. Finally, I'll just give you a glimpse of what I'm working on at the moment, which is the design of a new bio-based materials laboratory. This is a fantastic thing to be invited to do as the new chair. And it's on the site of the burnt down School of Architecture, which is of course the concrete Bakema building, which is now the Green Village, which has become a site of experimental construction. And that's the site for the Wood Studio laboratory building, and it's going to be for the whole campus to be able to carry on experiments and prototype building in bio-based materials. This is just an image of it. I won't talk about the design too much other than to say, you know, the collaboration with Diane de Kroon, ABT, neighbouring with their neighbouring offices, and then James O'Callaghan at Exley O'Callaghan, obviously the glass engineering specialist, means that, you know, my proposal for a hyperbolic paraboloid lightweight timber roof standing on glass above a workshop made entirely of reclaimed circular timber and hemp will be possible, and I hope on site next year, and that will be our home. Thank you very much.
Thank you. Thank you, Alex. Up till now, you weren't interrupted with questions. We only have 1.5 hours, so we have to rush on a little bit. But I have one question. Is the wood education, you can say, wood construction education, seen as an enlargement in Delft, or is it a competition between the usual education in concrete and steel, or is there an influence on the rest of the program that is changing to more bio-based?
Yeah, I think the agenda for every discipline on the campus is to reduce carbon, and therefore, whatever corner you might be operating in a very large university, the not just the necessity, but the pressure to be inventive about your particular material discipline means inevitably you are having to work with others outside. So I think it's a really good time to be there. I think it's a transitional period, and it's one where
does it help to speed it up, the thinking in bio-based or reducing carbon emission?
Yeah, I think what we're going to be doing in AE&T with our program of the invention and testing of materials and components, and with the new laboratory building to actually carry out testing, I think that will also up the ante, as they say in English. Do you know this expression? No. It's like everyone else has to try a bit harder. Yeah. That's what I hope.
Yeah. Okay. Any questions to Alex?
Sorry. I have a question to you. I have also students in my company.
Your name, please.
My name is Frank Razing. I'm working by Tritec. I have also students, but not high classes, but on the VMBO we call it.
Yeah.
And MBO schooling.
Yeah.
But do they also at the TU Delft learning how you make traditional home, where you have the floors from glulam and floors from wooden floors.
Yeah, balken and so
traditional.
Sure.
Traditional languages.
Yeah.
I know in my students, they what you say in Dutch, a muurplaat.
Yeah.
What's a muurplaat?
Yeah.
What's an hilde? What's a hanebalk?
Yeah.
They don't know it.
Yeah. Okay. Thank you. I showed master's studies, but at the undergraduate level, the BSc level, I'm also going to be running what's called a technology course, together with Steen Brankart, he's an associate professor. And what we're doing there is inviting not only undergraduate students, in their first, second, and third year, but also those who are already in their masters but think they have a gap in their knowledge. We're running a wood technology course which does address all the fundamental issues as well. So how you might build a timber frame house would be part of that course. Yeah. So that's a series of lectures and tasks. For example, we'll be setting them the problem of you need here's a 6 meter bulk, but you need to span 12. So what are you going to do about it? Yeah. So things like that. So they'll make their own experiments physically as well as computer studies for generating, analyzing statics, but also for generating form.
So this is another example of someone in practice, in working and teaching and researching. Is this important to you in your whole life, that researching and being an architect are aligned or are integrated in some way?
Yeah, that's why I like Delft, because there's so many people involved in industry and production as well as in academia and in theory. So I like the modernist architect Dennis Lasdon. He's kind of the equivalent of Bakema in the UK. He worked with Lebesgue, and he said theory without practice is blind, and practice without theory is deaf.
This is a good final word from you for now. Thank you. Applause. So next is Michiel Spaan. He's a known architect and teaching and head of architecture in the Academy of Architecture in Amsterdam. So the floor is yours.
Okay, thanks. Yeah, not anymore the head. That was a long time ago, but I'm teaching now for 20 years now at Academy. I have my own office in Amsterdam and 3H architects. We make mostly housing of concrete and brick. Still, it's a little bit a pity. We try to change, but the world is slow. But I think for 20 years now, I'm let's see how this works. Yeah, I'm working. I'm doing workshops with students. Maybe I have to start with I'm grown up with a parent and with a father and a grandfather who were carpenters, and I was always making things. So I always thought I started studying architecture not to become an architect, but to make models, because I thought it's nice to make things. But then in the end I came in practice and then I found out that as an architect you don't make so much. You have to organize that in the end things could be made. So maybe that's why I started this. So for 20 years ago I just started to I was already teaching, but I thought it's good for students that I saw that they were very often stuck in designing. I thought, why don't we turn the process around? We start with making something and then talk about it. Designing by making. This ended up for 20 years now in a program, and I wanted to stop already for a few times, but it doesn't work. It continues with a lot of different schools. It's for a long time now an international program, an Erasmus program, where we work together with different schools in Europe, all with people there that are also really into the making. We also work together with Gilbert on the chicken shed, so we and with a lot of other schools. There's this, and so we started. The first one was in 2004. And then we started just with fruit crates on a fruit yard, building with them, building objects and rebuild them all the time, discuss them and make them better. So this is this whole 20 years from we work with dry stone in Ireland. We worked with, of course, also with bricks. We worked with plywood, bended plywood, with wicker in Poland. And you see that more and more the wood comes in. It's a little bit of coincidence, but it happened. More and more we did in wood. Also, that because it's a material that you can easily work with, you don't need to have any knowledge to start with it. You can just build. Everyone can build with wood. And of course, then when you build it, you can see, oh, maybe when I do this, it becomes better, or when I do this, it can become. So it's a really interesting material with which you can test things and find out things. So this is the whole series. This was 2 months ago in Greece, where we worked with circular materials. Yeah, also wooden window frames. But I will take some of them out of it to show a little bit how they are about wood, and to try to get a little bit out of it what we could learn of this. I think it's a few things is interesting. It's about learning by doing, so it's making things. You shouldn't have too much knowledge of it, because then you get stuck already before you start it. Just build and then see what happens. And we always have very experienced teachers around. They know everything. So in the end, they can help the students to understand why something works or why something works not. But you start with a blank page. So learning by doing. And then another interesting thing that I learned is when you work internationally in different countries, that the context is very important. So we look in the Netherlands, a lot of examples of Japan or Switzerland or whatever, but they have a totally different context. Different kind of wood, different kind of experiences, different kind of crafts, different climate. So you need to understand these different contexts, also to understand what you could do in your own country. And when you are going abroad and you talk with Norwegians, then it's very interesting that they think about some things really different than we do. And that has a reason. And it's also good to know that, because you can make your own your own knowledge also better then. And another thing is working in groups. We always work in international groups, so that also students you cannot do things alone. You need each other. You need each other knowledge. You need also each other's hands, otherwise you cannot make it, because the material is heavy. So you need each other to build something. It's not architecture is not profession of solo persons. You have to work together. So that I think that's all very important things. So this is a few of the workshops we did in wood. I will go through of some of them, but I organized them a little bit in different themes about wood. It's about block construction, so stacking wood. It's about the skeleton construction. What's interesting that we in the Netherlands are really from the skeleton construction. That's also the roofs that you showed, the Dutch roofs and the ships. That's all skeleton, so it's used as less as possible wood to make a stiff construction. It's totally opposite than the Swiss and the Alpine wooden structure with the log construction, where you use whole trees on top of each other. It's the opposite way of thinking about material, so it's interesting. And another thing, at some workshops, it was really about the available tools. What kind of tools do you have, and how can you use these tools, and to which kind of details these tools lead you, because when you have different tools you can make different things. This is a workshop we did 10 years ago in the mountains close to Vaduz in Liechtenstein, where we built 2 log houses, and we didn't have big logs but smaller logs, so we had to combine them. So it was really about thinking about the log construction. The main detail is how do you go around the corner with the tree, because when you put them on top of each other you get a gap, so you need to find a solution for this corner joint. So students really worked on that, and you see one of them. So we worked with smaller planks, but you had to find an interesting way to go around the corner. And then we build it up, and you get to you feel it. It's also about the heaviness of the materials. When you make a 1 to 10 detail, 1 to 15, everything fits, and you can easily put it together. But when it's a 1 to 1, it's heavy. The material is not straight, so you have to. It's really the experience of the resistance of material. I think it's so important. We can all make all kind of nice renderings of wood, but when you don't know what the resistance of the materials is, it doesn't make sense. So you really need. For me, it's important that students get this kind of experiences. So in the end, it became some finished log houses. We didn't finish it all with our group of students. They finished it with some other students, but it's about, so in the end it's about a built structure that fits in this traditional site. What's also interesting, this is all pine wood, so but these houses are already for 100 to 150 years. They just stand. When you do something with this wood in the Netherlands, it's gone in 2 years. So talking about context, so it's so important that you know where you do what. This is another one where we were working with also with wood, but the idea was to make a sort of a roof structure where we use the bending of the bending forces of the wood to construct something. So this is some first tests of students in a smaller scale. So it ended up with I don't have them all here, but 7 different types of roof structures that could span the space we want to make, because in the end we had to make a workshop for the school. This is building the end. This was maybe 1.5 years later, but I just go quickly. But this is the final chosen structure. It's a very thin boards, long, but they are interweaving with each other, and so they become a strong structure. So, and it's a sort of a tent on 2 sides, and it becomes one space with a window at 2 sides. And here you see the outside cladded with shingles. So the workshop was really about this about the structure, and it ended up also to become a real building. Let's see, this is in Trondheim. this is one of the workshops where we thought we work with we give different groups of students different tools. So some of them only had hand tools, others had also electrical tools. We started the workshop also with a group with computer tools, but it didn't work, so we skipped that one. So we did only the because you should also make progress in a week. So otherwise you are only waiting for, as you said, for the cable. That doesn't fit. So it's also because all these workshops, it's 10 days, so you need to go fast. So this workshop was about making remake a truss of a Norwegian staff church. So we use the same shape, and actually so the shape was given, and each group had to make its own truss, 5 by 5 meters, with a few types of wood and with these available tools. So this is during the week making mock-ups one-to-one of joints and talking about them, how they could work and how they could use the tools in the best way, whatever. And then we go to the one-to-one scale of the whole truss. You see them with chisels and saws. This is really the hand tool group, and another group was working in a workshop with saws and electrical material. It was also really interesting to see how this process goes during the week. So we always try to evaluate that with the students on how did it work, and then you see when you make a joint by hand, it takes much longer when you can just saw it on the. But it doesn't mean that this joint becomes better or more beautiful, or so it's a lot of things going on. So it's always it's very interesting. It ended up with this structure with seven trusses. They all had the same shape, but they all have a totally different way of construction and joints. And just by making this and talking about it with the students and discuss it, you learn so much about there is never one solution. There's a lot of solutions, and it's in the end about which one do you choose and how do you make them then in the best way. So that's also this is also about that. So this now come back to the chicken chat of Alex. That was also one of the workshops where we also joined with TU Delft with Lauren in his workshop, cutting the trees into small parts, and this one was really also about learning about that we all talk about wood, but wood is nothing because it's about the type of wood. So we have oak, we have elm, we have robinia. Each type of wood has a totally different property. So when we talk about wood, it's still nothing. So you need to specify also to know what you are capable to do with it. So that's also things students should learn. what kind of wood then do you want to use, and how, and what can you do with this wood? So it ended up with you saw this one already, but what's also nice to tell about it, that it's the process of designing it is also really it's really about that there is not one person that designs it. So we started here with 5 groups. One group designed the construction, one group designed the roof, one group designed the facade, one group designed the night house. So each group designs a part and thinks about with which material is the best to make it, what kind of structure should it lead, and what do I need to hold it on, whatever. And then bringing students together and see if that leads to a final object. So this object was the conclusion of 4 days work separately, and then it came together, and then it leads to this. So the design is of 40 students and not of one. So that I think that's also a really interesting task and way that you can also design in a different way. But really starting from the properties of the material and what you can do with it, build it into components, and then these components start to become a building. Okay. Hij doet het niet meer. Ja. Even deze nog. Want Oh, sorry. I go too fast. Huh? Oh, ik moet terug. Kan ik terug? Ja, deze, ja. Ja, deze. So this one was also really about, because we made this shed in the workshop of Lorraine, but finally we still have to do that. We do that in September, so if you want to join, you can. You have to place it on in a garden in Haarlem for the municipality. So we made it in such a way that we can take it apart. It's no screws or whatever. It's all made by smart joints that you can you can take it apart again. So it's a demountable thing, but that leads to all these kind of interesting joints, all made by hand. And this is the whole group again. So and then the last project I want to show is this is last year. So we talk about we talked about reusing wood. So yeah, that's also interesting when you go to Norway and when you go a little bit to the farmland. When you talk about reusing wood or about circularity, they look at you and they say, "What do you mean circularity?" They build their sheds from the former shed. They always do. So it's just a tradition already for 300 years, just rebuilding. So we had the opportunity to demolish a shed and to make a new one of it. Actually, this one was also made out of a lot of other different sheds in the past. But so we demolished this one. We took it apart. We cataloged all the material. What do we have? Big beams, small beams, planks, whatever. Of course, they took the nails out, but we just did it by hand. Yeah, we had 50 students, so it's a lot of hands, so it was possible. but you see them working here. In the and then we the same as with the chicken shed, we worked in groups, thinking about foundation, thinking about structure, thinking about roof, thinking about facade, and then bringing it together into a new building. So here you see a group working on the trusses. We cheated a little bit because we had also some new wood to make connections. The 2x3'tjes, just the standard. School got them from somewhere, so they were there, and that was very good to think about joints. And so this is one of the trusses. Here you see trusses are standing. This is sort of a double beam made for the roof structure, and it ends with this. So this is when we had to leave after 7 days with this new shed. Made out of the same, with the same materials, and but look totally different. Okay, yeah, I think this is my story. To conclude a little bit, the future of wood construction. For me, I think it's important this design, material-driven design. So you start. I think that's it's all about. So it's not only about how the wood looks, but it's really about what it is and how you can use it. And so just be really aware of these opportunities of the wood. Think about components, making smart components, and build with the mountable joists. So I think wood is the best material to work with. You can always take it apart again. So think about that, and when you design something, and make it part of the design. That was it. This is a little bit. This is an interesting book, Crafting Wood. We made of some of the workshops. You can buy it on the Park Books. Published it, a Swiss publisher. It's of 3 years of projects we did, and this is also an interesting book. I wrote it myself, but it's about my 20 years of experience in doing this kind of stuff. So you can also buy it at Architectura en Natura or somewhere else if you want to know more. That's it.
Thank you. I would have some questions, but maybe anyone in the audience have a question at Michiel's? No one? Well, we're talking about knowledge institutes. This is a lot of knowledge in practical workshops you gain. How is this spread amongst the different institutes? Do you collaborate in knowledge and put it in books or in documentation?
Yeah, it's a lot in books. So actually all of these 20 workshops we made books or publications out of it, and in all of these publications, teachers, mostly teachers, sometimes also students, reflect on the process but mostly on the tactics of the project. So yeah, when I tell it now, it looks very simple, but the tactics is really important. So that you think about which framework do you give the student to work on such a project. So you need a sort of altogether sort of a perspective where you go. Otherwise, a lot of people fall off the train, and it's a pity.
Yeah. Well, it's very interesting to see all the European different kinds of projects. And you already said the context is really different in Norway, in Liechtenstein, in Amsterdam. Would you have a sort of advice for the Dutch next steps in the next few years in education? I mean, there's a lot going on, but
I think we look, but we are all busy with CLT and whatever, massive. And for me, massive wood structure is much more alpine way of structuring things. So I think our traditions is in the skeleton. So making smart, slim constructions. That's what we always did. And I think it would be good that we are going back to that more than we do now. Of course, we have a lot of hybrid structures, but our genes are in the skeleton.
Thank you.
That's also what happened already. Found out this morning, so I don't tell anything new.
No, but maybe the audience is new. So thank you, Michiel.
Okay.
So next I want to ask to the podium Frank Huiben. He is a lecturer and researcher, bio-based at Avans, but in the construction next in the Brabant and Zeeland. Yep. And your focus is more on bio-based in a larger, not especially on wood. Presentation is there. The floor is yours.
Okay, thank you. I'm just going to stand here just for a different perspective from you guys, from me as well. So thank you all for nice of me. I think I like being here. Let's see how you feel about it in a couple of minutes. I lead a research group on bio-based construction, and that's different from, I think, the most talk we had here is that I'm not a teacher, to get it out of the way instantly. I had some experience as a teacher as well, but I'm a researcher. So I'm leading a research group. We're doing research on bio-based construction, and we're doing it together with students. So that makes a bit of a difference, perhaps. Although TU Eindhoven is, of course, also research. And again, let me start before I start ranting off anything else. I try to go to the next one, but yes. To give it a bit of a context, our research group is part of a center of expertise that is called MNext, and MNext stands for the Material and Energy Transition. So we're actually focusing on the transition based on several themes. One of the themes is the bio-based construction, which is my research group, but we have 6 others based on energy-related or material-related topics. Not going to go into detail, but it's located at both Avans and HZ, which makes it also interesting because we're 2 regions, right? So North Brabant and Zeeland as well. Of course, I don't do this alone, and not even with students, but we also have dedicated researchers. So this is actually my team of researchers within Avans and HZ, and they were actually the ones doing the work. I consider myself mainly as the facilitator and perhaps the manager every once in a while. But they're actually the ones who do the real work. And I'm going to present what they are doing together with students and with companies. And why do we exist? And then I don't mean we as a research group, but in particular why we as a research group connected to HBO, so University of Applied Science. I think it was nicely put in this book, a Dutch book called Op onderzoek uit, which says that, I'm just going to read it out loud, but you can, of course, read it as well, that through practice-oriented research, universities of applied science form the bridge between scientific knowledge and and professional practice. So lecturers, teachers, researchers, and students feed on questions from society and enrich that society with their answers. And that's exactly what we're doing. So we have questions from companies, from governments, and we're going to see if we can have a question on those answers. And we do that together with students. So in that way, we also innovate the innovation. So we put the students with their feet right at where the problem is in society and try to look for ways of dealing with those issues, often societal issues. But if we look at my research group, then we actually said, okay, let's have a vision, right? Because even I'm doing this for 1 year now, but the research group has been there since 2015 or 16. I'm actually not sure. And we're striving to go to, our vision is to reach to a healthy and a sustainable built environment. And truly sustainable, which is like in harmony with nature. I also have an image to express that in a minute. And we're actually doing this by bringing innovation on the field of bio-based construction to society. So together with companies, we help them out. If we don't do our work right, if we don't help the students, we don't have good education, we don't have good practices that have answers for the questions. A lot of companies, of course, and perhaps some of you already know, it takes time and money to do innovation, and companies typically don't have the time and money, and researchers at a university do that. So that's where we can contribute to the problems and to help out. And within our research group, we have made the focus on 2 specific aspects. One is the most important one, which is health. So if you apply bio-based materials to the built environment, how does it contribute to the healthy living environment? So how can we improve the living space and not have headaches at 3 o'clock, but still be vital and enthusiastic? So I'm also wondering about this environment today, of course. And the other one is environmental sustainability. So if we do it with materials, do we create waste in the end that we put in buildings, or do we actually have nutrients that can be used over and over again in a biological cycle? And this is actually the image I was referring to before, which expresses this. Very simply put, this is like the cycle of resources. It starts out with Earth, right? And it has a lot of resources. From a resource, you can have a material. From a material, you can create a product. With products, you can create building elements. With building elements, you can create a building, etc. And then you have a usable object in which we can live, but it should also be a healthier environment. It also, if we want to have the circular aspect, it also has to have a way back. So typically in the building industry, we work towards a building. That's it. And we would like to say, okay, that's only like an intermediate phase. It has to some extent, the materials should be able to return to nature, or to some extent. So that also depends on how do we connect the elements, how do we glue them or not, or what are the methods of connecting building materials. But first one back, just to express within our research group, what are we focusing on? So basically, if you look at the building industry, you could say we have building and, material and product development, but we also have building technology. So how can you use materials? How do you technically compose them into a good building? And thirdly, how can you actually have the performance of the buildings demonstrated, so you can actually do it and show that it can be done. So if you look at how some very brief examples of what we're doing, what type of research we're doing, and with every research we are actively involving students, could be interns, could be graduate students, could be minor students, but it could also be like free courses that they can choose along the way in their curriculum. One of our core materials, like new materials in the building industry that we're researching, is mycelium. Mycelium biocomposite, I must say. So we're typically using, I must ask, who hasn't heard of mycelium before? And it's not a bad thing. Some few hands. Well, then again, the left image shows it, I think a bit more in detail what it is. Everyone knows the mushrooms. the root structure, although it's not the root, but the threaded structure underneath, that's actually the mycelium, and you can use that to create building objects, or building materials, I must say, which turn out to have like beneficial insulation properties, for instance, but also structural properties. And we're investigating to what extent can this have certain properties that we want in a building. And then step 2 is, okay, let's do it and let's test what the lifespan is, or how does it behave if we put it inside a building for a long time. So this also requires that we have our own mycelium lab, which is strange because it suddenly becomes a building environment where we have white coats and glasses, which is a bit strange. We heard people talking about building with wood. Of course, timber, it can be done like go outside and you can do it. Well, with mycelium, you can't. So that's a different field, but then again, it's also something still quite new within the building practice that we want to explore and to see to what extent can it actually be a material that's viable. That's not only theoretical, it's something that can happen, but it can actually be applied. Based on the research, we published several white papers. Feel free to check them out. mnext.nl, that's the basic point where you can find anything. But next to that, it's also building technology. And here you see students. I think I'm not going to show a lot of these images because we've seen a lot of them today. Together with students, it's good to experiment, to say what a certain theory is, and then to try whether we can make that theory also happen. So typically, basic working on new construction systems. In this case, it was a structural applied straw, which is not very common in the Netherlands. It is a bit more in Switzerland and companies like or countries like that. And to make pavilions and to showcase that it can be done, and of course having students hands-on experiencing what it is to work with those materials. Another thing we do, which is very important if we talk about health, is of course we need to monitor what does the materials do to the indoor climate. So we have, for instance, facilities, that's on the right image, the very small ones. We have two climate, well, we call them climate containers because there are two containers. But in fact, there are climate chambers, so you can climatize both rooms independently, and we can model a fully facade for 3 by 6 meters, so full scale. And then to test on what does it, if we apply bio-based materials inside a facade, how does it behave in terms of moisture or temperature, etc. So part of the facilities to actually show that it can be done. And just to show some examples of the types of projects that we have been working on based on research that we included students with. We've been doing this for a couple of years, and I'm actually saying I would like to have seen these pavilions realized based on a research that we did with companies, but it's typically that we have researchers that had the idea to have a education program based on this idea. So the knowledge that they gained in research got to the education part because of the person they were, because of the researchers. And we're now more and more in the development. If we're doing the research, why not connect it directly to the curriculum, which is like always the struggle time-wise, but it can be done, and that's something that we're more investing in. But then again, you could see that there's quite some pavilions that have been realized, and of course, if you have those buildings, you can do monitoring on how do the materials behave. Is it something new we tested? What was it? How can we give this knowledge to the companies that are actually trying to use it in practice, and just to share knowledge, because we're a knowledge institution, right? So we don't want to keep the knowledge to ourselves. We want to spread everything that we have based on the knowledge. And also the fun thing, because I see a lot of nice design things, and don't mean this very bad, I mean this very positive. But what we try to do is that we have a question from a company. This is what basically this image tries to say. That we have one group of students making a concept or a design, and they pass their knowledge to a next group of students, might be next semester or next year, and they're going to do the engineering. And the next phase could even be next semester, the students are going to do the actual realization. And another group of students are going to do the monitoring, etc. Then we have a sort of a closed loop. because based on those realizations, new questions arise, which lead to new designs, etc. So we have a continuous stream of doing this. So you could see it as like a relay race. In Dutch we say estafette research. And just to explain one of them, we have two graduate students who are nearly finished, and actually one of them is in the room. I think only one. Jaro, welcome. He's sitting in the back. One of those design tasks from students was to create the wiki house. I think most people know the wiki house. If not, look it up. It's very fascinating. It's the image on the right that's explaining how you can build with a standardized prefabricated, digitally produced elements in the building industry. And students are currently realizing a building at Hendricks Koppelmans, I forgot the name almost. It's a company who want to invest using the system but make extension housing, so seriematige woningbouw in Dutch, which is difficult in English. But this is not the research that we as a research group are working on, but the two students had made like a parallel study. Okay, if we have the concept, how can we make this fully bio-based? Starting out from a couple of materials that we can use. And if we want to make it bio-based, then we can't use any foils to have it like vapor tight or to keep the moisture in or water out. So they tried actually to make the system vapor open, which was already pointed out before that it can't be done. So it's quite a struggle to start. And I can explain that actually they figured out that it can be done on theory and in simulations. And of course, we're gonna do the follow-up, which is gonna do the actual measurement that shows that the theory and the simulations are correct with the reality. But to give some sort of very brief introduction, and if you want to know more, please talk to the student in the back because he knows way more than me about this project. Basic conclusion where it comes down to is that one side of the wiki house, it's a concept based on wooden boards, and they are both the same. So if you want to have a vapor open structure, and I don't know if I'm going into too much detail for some of you, but then you need to have one is more vapor open than the other one. And how to reach that is, well, it could be by puncturing it, very simply put. So the students actually made several designs on how to do it, and they came up with a certain pattern that it can be done. It turned out that it can be done structurally as well as building physically. Again, we have to test this in practice, but that's the next fun step to do. And by using all sorts of materials that are purely bio-based, and I won't dispute the use of loam, like the loam plaster, because we're looking into using materials that can be brought back to nature or can be used over and over again, and then loam is, of course, one of the perfect materials for that. But what it comes down to is that they find a way to do it, and also I talked to people from the Wiki House. I don't know if they're here in the room today. I talked to them this morning. They were very interested in seeing how can we use this in a follow-up maybe, so it's gonna even have more extension on this. And this is where we can show that, well, doing research for companies with students can lead to all sorts of developments. And of course, the knowledge that's gained here doesn't necessarily need to be used only with WikiHouse. Can be used like in all sorts of projects because it's still wooden boards, and we all use wooden boards in structures. And that's it. Thank you.
Thank you. Well, there's room for one question before, otherwise there's no time enough for Marta. Is there any question? No? Is there, my question is there some sort of collaboration you think is useful between the different institutes?
Definitely.
The four of you, for instance.
Definitely, yeah. And we also already collaborate, not per se with the persons, but we work together with the University of Eindhoven, but also Delft. In particular, we also try to work with MBO, because if we want the students how to learn to use materials, it's probably not the thing that the HBO students are going to do in practice. No. But we need to involve the people who are, which is typically MBO, and they need to have, if we have a new type of material, let's say inblaas isolatie, it's a new trade. It doesn't exist yet. So how do you learn those students to get those knowledge and that knowledge? So there's always the connection. We need to look.
The answer is yes.
Yep.
Yes. Thank you, Frank.
Yep.
Applause. Marta Male Alemani. You're the associate professor of digital production at the HVA, the University of Applied Science. And you're talking about the robot lab, I think, which some of us visited this morning, and it's very interesting. So the floor is yours.
So how many of you were at the robot lab this morning? Okay, good enough. So for the others, first of all, let me say, Hans, Bob, and also Alex, Michiel, and Frank, I'm super, super happy to be here. So I think that only being here, we are creating a kind of community. And I would like to say up front that the robot lab is your place, is open, and I hope that we can talk about it in the future. So this is the robot lab. Some of you have been this morning at the robot lab. And well, I want to say that the robot lab did not exist 6 years ago. It has been built up really bottom up. The faculty also did not decide to have a robot lab to begin with. So what it is what it is, because we made it so. But this is a kind of slide that we made already at the beginning, and we said, we declared that the robot lab was going to be a place where education, research, and practice meet each other and integrate with one another. So it was clearly declared like this. We wanted to explore the capacity of digital production to add value and to address some urgent societal challenges. It's a place where basically it's complex because we are part of a faculty of technology that is 7,500 students from 7 different programs. So we have a multidisciplinary crew. We are running a research group that is actually powering the robot lab, and we have many partners in project. But I'm going to fly through this because many things you will recognize, but we work very much empowering the students, learning by doing. That's our DNA. We didn't know anything 6 years ago, and now we know a little bit. We are a very multidisciplinary team of architects, engineers, mechatronic and robotica programmers, sustainability experts, and more. And basically, this is us. We are connecting 3 of the profiling themes of our faculty. We work on smart industry, obviously, because we are working with robots. There is where our design and production technology is the field where we are acting on. We are looking at the circular transition as one of these urgent societal challenges that we want to be part of and want to work towards. And we are also aiming to build future cities or to do impact applications. We are very much addressing some of the urgent issues of the city, obviously, like the circularity, as I said. And basically, these are very, very quickly some, for us, in the end, this is what it's all about. We know that 62% of waste wood comes from renovation. It ends up at collection sites. It's 2/3 of it is actually burned for energy recovery. The other 48% is downcycled into chipboard, and yet the demands for wood, as we have seen, are rising. And in the end, the Netherlands has only 10% of forest territory, which basically means that only 5% of what we need here is actually sourced from the NL. And we also are looking at how to increase circularity, working with the manufacturing industry, because this is a pile of beautiful wood that is also waste created by the wood manufacturing industry. And what we are doing at the robot lab is to try to see if we can use this smart industry, let's say digital production, smart industry production, to enhance or to accelerate the circular transition. So it's been some years already that we have been working with wood, with this idea of using residual waste streams that obviously, because they are residual, they are non-standard by nature. They come in different sizes, different types, etc. and to apply to these design from availability principles with computational design, and to basically use robotic production to make it possible to make things out of this wood. And now lately we are moving into digital twinning to kind of simulate what we could do up front and to try to elaborate business cases out of it. These are only a little bit of a demonstration of our research partners, because we are running many research partners, and this is only until 22. There are many more now, no time to update it. Well, this is projects like this, DataWood. It started already quite a few years ago, but this idea of if you have a variable waste stream, basically if you want to work computationally, you want to digitize and you want to understand what you have. So this idea of creating a digitalization of waste streams. And this is a project that we did already 3 years ago. What for some people is 7 days, in this case is 7 years. Well, so be it. This is a project that we did in which we really tried to establish the methodology that we use at the Robot Lab. And this was about designing with a waste stream and really thinking, what can we use algorithms to basically, parametric design and algorithms to localize and to optimize the position of the wood in a structure. So this is a very simple reception desk that is now installed at the Johan Cruyff Arena, but where we were able to create a gradient of color of the wood and to really work on these circular design principles of designing for disassembly. We used the robots to make all our joints, and in the end, we ended up building this reception desk. And it was just a test, but in the end, we basically made a lot of declarations with this desk, and we were very happy because these are 300 pieces of beautiful hardwood coming out of the wood manufacturing industry leftovers that were going straight to the incineration plant, and instead they became this desk. So ever since, this is what we are busy with at the Robot Lab. Ever since, we are asking ourselves, if we were able to somewhat put smart industry tools to work with this, is there a possibility that we would start with leftover streams from, for example, the wood manufacturing industry and end up with material-driven and custom products in the end? And how can we automate, or how can we make these possibilities, basically? So for us, what it means is we work with a database of residual wood. We work with computational design tools that are able to look into this database and make reservations of this database. We work with robotic production. We try to automate certain processes. We try. We are now moving into digital twin to simulate what we're going to be doing in this kind of factory and to explore the business case of it all. Because we want to calculate, and we are able to calculate also the impact that we can make by using circular wood as opposed to using new wood. And for instance, now we are working on a case study in a project for designing for hospitality using circular wood from wood manufacturing industry. We are taking the case study of the stool from Piet and Eyck, so-called made by residual wood. Our vision is that could you make this kind of stools in a continuum if you had an incoming stream of material that is always variable and different? And for that, well, we are exploring different strategies. One that is, let's say, form-finding strategy, which is, if you have a certain amount of material, certain pieces of materials, and you have a sketch, can you adjust your sketch a little bit? Can you adjust your parametric design model to make best use or optimal use of the resources that you have available, as opposed to basically having a fixed design and basically looking into the database what kind of elements I can use to make this. This is not so simple because, in fact, the stool, for instance, is made out of different parts. The original stool, for instance, you take the top here is made out of 5 parts. But if you had an available material that would suggest that this tool is made out of 3 parts, then all the relationships between the parts would also change and would need to be adjusted to it. So we are exploring projects that are eventually able to generate design systems, if you want, out of incoming streams of material or database of certain materials. Now we are busy with a project also in developing this kind of wooden surface, modular wooden surfaces out of it. And we are building design generators, if I may say, on the basis of that wood. At the end, we would like that these design generators are also able to calculate impact, and we are already working on this, so that you could compare, okay, this is the wall that I could make. If I was using new wood, this is what it would cost, this is what the impact would be, this is what the emissions that I would create. But if instead I was using circular wood, then I would be able to reflect and eventually take a different choice. We did some projects also in looking at waste wood from construction. With this project called Circular Wood for the Neighborhood, we won the Best Research Award in the HVA in 2023. We were basically looking at the wood that comes available from building renovations and building demolitions, from housing corporations. We took projects, we did a survey, we really analyzed what kind of wood was coming available that ends up either incinerated or downcycled into chipboard. Then we thought that we can help by looking into, can we use robotics to actually process this waste wood and make it available for new applications. We always work in the lab making what we call conversation pieces. And these are prototypes in some way that want to showcase what would be the potential, what would be the possibilities, what would be the difficulties even. And this is a window frame made out of remanufacturing or cleaning up pieces from old window frames with the robots. And of course, it's a conversation piece. It's all crooked on purpose, just to say that you cannot pretend making windows with elements that are, if they are damaged, they cannot have the same length, etc., etc. And what kind of possibilities emerge when you start looking at these waste wood as systems, material banks? Anyway, so we had different visions about how we could use these in interiors. This is done during pandemic. So, but also the housing corporations maybe could make this wood available for community projects and so on. So I'm going very quick, but I'm trying. So we are now working on a European project. It's called Wood Circles. We are in charge of this idea of an urban sawmill that is basically able to take wood from the urban forest and turn it into sub-products for example, CLT. And we are busy with what is this urban sawmill, and what kind of value can it create by processing this waste wood, and what needs to happen, and so on. So this is not an easy topic, as we all know, because it has contamination, metal, all kind of stuff. And in the end, we are really trying to make sense a little bit of how much technology do you need to put into this, and for what kind of complexity of wood, and when there is a moment that you pass this material value. So like to find the sweet spot about where and how this kind of technology would make sense and when it doesn't make sense, which is a little bit also what we're busy with. And we have ideas about what would it mean if, for example, we were able to decentralize part of this technology and to bring it as close as possible to the sourcing materials, let's say, for example, to demolition sites or collection sites and so on. These are new projects. We just have applied for a project at the Van Dijsselbuurt here in Amsterdam, but the intention is that we are going to go on location. We're going to follow up on this idea of making something with the community, with wood that is extracted from actual renovations and actual building demolitions. We are partners with, for example, the housing corporation Rochdale. They have a restructuring project for 10 years in the Van Dijsselbuurt. The Van Dijsselbuurt is one of the 20th more vulnerable neighborhoods in the Netherlands. And we think it makes a lot of sense to basically use the resources that come available from this neighborhood for the neighborhood, involving the local community and involving new technologies. So this is not a project from us, but we imagine that in the end we are doing urban demonstrators like this. I'm almost done, huh?
Yeah, I know.
And basically where things like this are possible with wood that has been harvested on location from those buildings and working with the community to do this. And that's it. Last but not least, this is a new project as well. We are looking into reusing pieces of wood from fallen trees in Amsterdam, from Stadsbosbeheer and more, forks and branches that are basically leftover wood as well, that basically are not interesting for the timber industry. So with our robots and digital production, we can probably make use of it. And this is us beginning with it, just beginning at the lab. And that's it. Thank you very much.
Thank you, Marta. You've done a great job in a very short time. Thank you. We're out of time, actually, but I would say let's take another 5 minutes for some questions. I mean, we still have time for the next. Okay. Heb je naam ook?
Hi, I'm Ferdinand. My question was, do you also focus on wood chips and sawdust, or is that out of the scope?
Yes, no, all of it. Yes, let's say we have also the possibility to do robotic 3D printing in the lab. Dream come true would be that the lab is busy with absolutely every possible production process that would involve robots and wood, say. But the thing is that the wood projects to begin with were never intended to be the center stage of the lab. It's just, it started and we keep on working on it, and it's because it's never ending and it's so interesting and it's so much and so necessary. So I think that the answer to your question is the lab is ready for it. We are, it's only a matter of capacity and only a matter of wish. But really at the moment, for us, any related project to what we are doing and involving the technology that we have in place would make a lot of sense, actually.
Oh yeah, thank you. Yeah, that was super interesting, and it got me thinking about the destination of circular wood. Typically it's salvaged and it's of a certain length, and then it gets cut down in order to conform to a process or a geometry or a possible application with smaller dimensions. I was wondering whether the robot lab could take on the challenge of taking wood from construction industry and then making it bigger and putting it back into the construction industry.
Yeah, this is already happening. So the thing is that companies, for example, like Wood Join, are already taking wood, finger joining it, and putting standard beams back in the market, let's say circular beams, to be used by the construction. But the thing is, we are exploring, and maybe naively, it's okay, but we are exploring a kind of a world where if you have already the parts, and you can make sense of those parts, and you can make objects, and you can make things with those parts, why go through the process of finger joining and then cutting them again to make those objects? So we are exploring, let's say, shortcuts or avenues that are maybe less obvious. But for example, in the Wood Circles project, because it's a massive scale, then the idea of creating sub-products that are standardized, that are certified, etc., is what you need for this massive production of CLT. In that project, we are trying to see if there is a possibility to put waste wood or circular wood in the middle layers of CLT. And there, well, it's interesting because we are discovering a lot of things. For example, the fact that the current certification of CLT, as we have it, does not account for lamellas that are made with a lot of finger joining. The certification is done on lamellas that do not have finger joining. So, or very little, let's say. So these kind of spaces for circular wood, we have all these projects. They are kind of like pieces of an overall puzzle. For some things, like if you're going to use it for hospitality, as an example, then you can totally make use of the wood that you have in variable parts and variable things. You know, it seems. But in other kind of applications, you would want to maybe then put it together as more standard elements. So I think that this is a cloud of possibilities in a way. And in the robot lab, we try to create the tools and the processes and the methodologies that allow a little bit to navigate this cloud. It's not always one straight answer from what we have experienced so far.
Thank you. Well, thank you, Marta. In the end, I would like to say I'm very much impressed by seeing what is happening already in all the schools. I was educated in Delft 50 years ago, and so much has been changed. And I think this change is in the way that the world is getting better, but it's not fast enough. We have to speed it up again. And I think this helps in the community, as you say. Being a community is, we need to be much larger, and so many more of the industry should be involved. I think this is very important, that the education, the knowledge institutes and the industry are really working together. And this is happening already, but not enough, I think. So this is one of my conclusions. And the other conclusion is next year, with the next edition, we need to use this knowledge and bring it further. I think this is so important also for the younger generation. We should invite more younger generation here, I think, to learn what is happening. Thanks for all the speakers, and another round of applause for them.
Can I make a suggestion?
Yes?
I think that if you're going to do it next year, with this crew of people, it will be very, very, very nice that there is a prior workshop for students, and that eventually, you know, that prototypes are made, that things can be shown, not only like as in the form of lecture, but that we really, really, really bring it into our schools and involve the students to do that prior the Houtbouw.
Thank you. Good suggestion. Thank you. Okay, see you next year. At least.